Hello everybody, get ready to do a lesson in pre-calculus math today. If you need solution PowerPoints or if you need note-taking guides, email me here. Today we're going to do 4.1 Radian and Degree Measure. You have 6 points here in your notebook and a 50-point classwork lesson today. Again, I got note-taking guides for this. Contact me for those. Teachers, today's bell work. Sketch the graph of x cubed, and then graph the function g, describe the transformation. So you have to graph this, and then graph these, students, and then describe the transformation. Put that in these boxes here, your description of the transformation. Teachers, give your students 5 minutes. Okay, welcome back for your solutions today. For your bell work up here, okay, the graph of g is a horizontal shift to the right. This negative, I mean you're going to the right here. 1 unit to the right of f of x equals x cubed, which is this graph here. This is x cubed here, and then this is f of x minus 1 cubed, which moves over here 1 unit to the right here. So this is x minus 1 cubed here. And then down here, x cubed, again, that's your graph here. Then we have x cubed minus 4. So we're going to move down 4 units here. We're down here. So this is your x cubed here. And then this is x cubed minus 4, so you just shift down here 4 units. And then here's your graph for g of x equals x cubed minus 4. Okay, notebook. Get your notebooks out, students. Page 1 in our lesson today. Greek language. The word trigonometry means measurement of triangles. Initially, trigonometry dealt with relationships among the sides and angles of triangles and was used in the development of astronomy and navigation and surveying. For the development of calculus and the physical sciences, 17th century, a different perspective arose. One that viewed the classic trigonometric relationships as functions, with a set of real numbers as their domains. Consequently, the applications of trig expanded to include a vast number of physical phenomena involving rotations and vibrations, including the following. Notebook again. Sound waves, light rays, planetary orbits, vibrating strings, pendulums, orbits of atomic particles. An angle is determined by rotating a ray, half line, about its endpoint. The starting position of the ray is the initial side. So we're starting to get into some trig terminology here, an angle, and then initial side of the angle, and the position after the rotation is the terminal side. So we're going to get more into initial side and terminal side. This goes into your notebook. And then this is an example here of vertex. And then initial side, then we rotate this way to our terminal side, and then, well, we'll get into that later, but that's a good diagram of these definitions down here. Again, another notebook entry. The endpoint of the ray is here is where the vertex starts here. The endpoint of the ray is the vertex of the angle. Here would be your vertex here. This perception of an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis. This is the positive side here of the x-axis is on this side. This is your negative side over here. Such an angle is in standard position. This is standard here. Positive angles are generated by counterclockwise rotation. So here being your initial side, moving this way, that's the positive angle. That produces a positive angle here going counterclockwise. And then going clockwise is a negative angle. That would be a negative angle when you start here and then go this way. When you go this way, that's a positive angle. On to a classwork sheet. Okay, angles are labeled with Greek letters such as alpha, B, I guess that's a B there for beta, and then theta, as well as uppercase letters such as A, B, and C. Note that angles A, alpha, and beta have the same initial and terminal sides. So this would be alpha here, but beta goes around 1 revolution and then this much more. So beta is 360 plus alpha here. Such angles are called coterminal. So because they end at the same place here, they're coterminal. Okay, so page 5 on your classwork sheet here. Radian measure. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. One way to measure angles is in radians. This type of measure is especially useful in calculus. We'll get into that later. To define a radian, you can use a central angle of a circle, one whose vertex is the center of the circle, like this here is theta. This would be your central angle right here. These are radius, this is radius, and then S here is actually part of the radian calculation here. S equals R. Definition of a radian. 1 radian, or rad, is a measure of a central angle theta that intercepts an arc S equal in length to the radius R of the circle. So what the world? Algebraically, this means that theta equals S over R, where theta is measured in radians. So radians is it is a ratio between S and R, and S is the arc length, and arc S is equal in length to the radius R of the circle. So theta in radians is the arc length over the radius. Because the circumference of a circle is 2 pi r units, 2 pi r units for the circumference of a circle, it follows that a central angle of 1 full revolution counterclockwise, like this, corresponds to an arc of length of S equals 2 pi r. So 1 full revolution is 2 pi r, would equal S. So 2 pi equals 6.28. Pi is 3.14 approximately, so 2 pi would equal 6.28. So there are just over 6 radius lengths in a full circle. So here's like 6 radius lengths here. In a full circle you have 6 here and then a little bit more, which is your 0.28. So that would be how the circumference is figured, is 2 pi r. And then 2 pi would be 6.28, and then r you throw in the extra amount here would equal your full circumference. Because units of measure for S and R are the same, the ratio S over R has no units. It is simply a number, simply a real number. Because the radian measure of an angle of 1 full revolution is 2 pi, the radian measure, you can obtain a 1/2 revolution would be pi radians, and then 1/4 revolution would be pi over 2 radians. Using 2 pi as a full revolution, then 1/4 of a full revolution would be pi over 2, and then 1/2 of revolution would be pi radians. And then 1/6 of a revolution would be pi over 3 radians, like that. These and other common angles are shown here. So we got pi over 6, pi over 4, pi over 3, pi over 2, pi, and then 2 pi. This is a full revolution. And then we have quadrant 1, 2, 3, and 4. And then this is less than, whether it's less than pi over 2, greater than 0, etc. Here, pi 2 is this part here, or rather the second quadrant. Third quadrant here is this part, and then the fourth quadrant is this part here. Recall that the four quadrants in a coordinate system are numbered 1, 2, 3, and 4. 1, 2, 3, and 4 quadrants. Two angles are coterminal when they have the same initial and terminal sides. For instance, the angles 0 and 2 pi are coterminal, as are the angles of pi over 6 and 13 pi over 6. You can find an angle that is coterminal to a given angle theta by adding or subtracting 2 pi, or 1 revolution. So, for example, theta equals pi over 6 is coterminal with pi over 6 plus 2n pi, where n. Okay, moving right along here to page 10 of our lecture today. Sketching and finding coterminal angles. For the positive angle theta equals 13 pi over 6. So 13 pi over 6 is 1 full revolution plus pi over 6. So this is the terminal side of this angle here. So we're going to find something that's coterminal with that. So what we're going to do, we're going to subtract 2 pi to obtain a coterminal angle for that. So to subtract 2 pi to find a coterminal, we go back this way, and we have this angle here. 2 pi would end up here. So when you do a 13 pi over 6, you come up with this, and then when you subtract 2 pi, you go back the other way here, like this, and then this would be the terminal side of your 2 pi to obtain a coterminal angle. And then for B, this is B here, for the positive angle 3/4 pi. So positive angles go in this counterclockwise. This is 3 pi over 4. And then subtract 2 pi to obtain a coterminal angle. So well, the way we're going to do is we're going to subtract 2 pi. So to subtract 2 pi, we got to go back this way, and then we'll end up here is where we'll end up. This will be 2 pi here. I mean, if we started here, 2 pi would be all the way over here, but we're starting here. So when we subtract, we go 2 pi in this direction, and we end up here, where the original 3 pi over 4 was the terminal side. When you subtract 2 pi, you end up right back over here as a terminal side of the subtraction of that. And then for the negative angle, negative 2/3 pi. So negative, we go clockwise. This would be negative 2/3 pi. And then to find a coterminal angle, negative 2/3 pi plus 2 pi. So we go back around this way again for our 2 pi, and we get 4 pi over 3 is what we get there. That would be coterminal with the negative 2 pi over 3. Okay, into our guided practice. Determine 2 coterminal angles in radian measure, 1 positive and 1 negative for each angle. There are many correct answers. Oh, great. Okay, so here, 25a, we have theta equals pi over 6, so coterminal angles for pi over 6. That's what we need to find. So we're going to add 2 pi to pi over 6, and that'll give us 13 pi over 6. So we can go that'd be 2 pi, that'd be 12 over 6 pi, then one more pi over 6 will give us 13 pi over 6. That'd be one coterminal for pi over 6. And then pi over 6 minus 2 pi. So now we can go this way now, 2 pi, and that'll give us a negative 11 pi over 6. So if we start here at our terminal side and go back around this side, we'll have a negative 11 pi over 6 in our rotation in radians, and it'll end up here at this as our coterminal, or rather our terminal side for this original pi over 6 angle. Degree measure, a second way to measure degrees, is in terms, or rather a second way to measure angles is in terms of degrees, denoted by the symbol right up here is your degree symbol. A measure of 1 degree is equivalent to a rotation of 1 over 360 of a complete revolution about the vertex. So here is a circle here with all the degree measurements for rotation. To measure angles, it is convenient to mark degrees on the circumference of a circle. So a full revolution, or counterclockwise, responds to 360. A half revolution is 180. Here's 180. Here's 360. A quarter revolution is 90. Here's your 90 here. And so on, because 2 pi radians. Okay, so here we have our circle again with our degree measures. 1 complete revolution, degrees and radians are related by the equations. 360 degrees equals 2 pi radians. So 180 would equal pi radians. This would be pi. 360 would be 2 pi. That'd be 2 pi over here. And then 1 degree will be pi over 180. Radian would be about right here. 1 degree. And then 1 rad would equal 180 degrees over pi. So there will be a radian measure there. So conversions between degrees and radians. To convert degrees to radians, multiply degrees by pi radians over 180. So to convert radians to degrees, to go backwards, multiply radians by 180 degrees over pi radians. So we just invert it for that. To apply these two conversion rules, use the basic relationship 1 pi radian equals 100 degrees. So knowing that, when no units of angle measure are specified, radian measure is implied. For instance, theta equals pi or theta equals 2 implies that theta equals pi radians or theta equals 2 radians. So here's angle measures here, pi over 6, pi over 4, pi over 3, pi over 2, and then pi, and then 2 pi. So pi over 3 is 60, pi over 4 is 45, pi over 6 is 30, pi over 2 is then 90, and then 1 pi is 180, 2 pi would be 360. Converting from degrees to radians. So 135 degrees, using our conversion factor here of pi radians over 180 degrees. These cancel, so we have 135 times pi radians over 180 will simplify to 3 pi over 4 radians. So 135 degrees is 3/4 pi. Now 540 degrees, again using our conversion factor here, we do our canceling, then 540 times pi radians over 180 will give us 3 pi radians, again using the same conversion factor here. And then negative 270, when we multiply that into our conversion factor, we'll get negative 270 times pi radians over 180 will give us a negative 3 pi over 2 radians. Okay, knowing that, and going into our next guided practice, rewrite each angle in radian measure as a multiple of pi, and do not use a calculator. So we have 30, and then we have a 150 here. Students, this is yours. So let's do our 30 first. Using our conversion factor, we get pi over 6, because this will cancel out here to 6 and 1. So 30 degrees will be pi over 6 radian measure. And that is your lesson for today, 4.1, Part 1, Pre-Calculus Math. Email me here for PowerPoints and other materials. Thank you very much.